So here, talk through this Japanese sums puzzle by Prasanna Seshadri called 2020 Vision. That theme in part comes through these 20s, which can be as small as 3 numbers long, like 3 plus 8 plus 9. They can't be smaller than that. And they can be as large as 5 numbers large, but they can't be larger than that. 21 is the first sum that can be 6 numbers large, 1 through 6. So this is the 3 to 5 group in all cases. The other interesting constraint in this puzzle is these are actually all double-digit clues, but they're single clues, so they can be 2 up to 9 cells long. This is a 1 to 9 puzzle. And actually, I'm seeing that 9 to 9 grid is going to give us some of the starting constraints, which are looking at the columns. And let's start with this first column. This column has 3 larger than 1 cell sums. They're all 2-digit sums. So these have to all take at least 2 cells. And so in a small grid that's only 9 cells large, look at the fact we have 1 degree of freedom. If we took the minimum space of just a 2-cell group, 2-cell group, 2-cell group, we have 1 degree of freedom. And so this sum can move up or down 1, but it always uses this cell. This sum can move up or down 1, but always uses this cell. And in the same case, this sum always uses this cell. So if you're not familiar with this kind of logic, these fixed cells when we have 1 degree of freedom are pretty key here. And the same thinking applies to the 5th column because we also have 2 cell sums there. At a minimum, maybe as many as 3 cells, but there's 1 degree of freedom to be had anywhere in the space. We're going to take 1 extra cell as black. So we've marked these in, and those work immediately with the 20 clues to say these 5 cells are the 20 and no more. These 5 cells are the 20 and no more. And these 5 cells are the 20 and no more. And still not a lot to do on the left side with that, but marking all the space now in black is probably going to interact with these smallish clues, except for the 16. The 16 is pretty large. Has to be at least 9 and 7. And that's actually the only thing can be in this grid, and it's got to be down here. You can't use these other spaces. That's going to leave just enough room to put in a 3, and it's got to be a 3, not a 1 with 2. And then the single digit 1 at the top. So this looks like the second step of the puzzle after getting these rows identified. This top row looks the most important after doing that. It can't now only take cells to the right here to get up to 20. It's got to take at least this cell, which gets us to 9. Those 10 can take 3 more, but not these 2 cells. We mark these off, and this is the degree of freedom we said the first column had. It's now gone. So 2 and 2 and 2 is required now. That's 8 and 9. For the 17, 12 can be 7 with 5, but nothing else. And with all these specified, we need 1 digit larger than 5 here. That has to be the 6, and that pairs with the 4. So this is how those go. 2-digit sum means this comes over, this comes over, this comes over, and actually this one has to connect. These greens always have to connect. That's what this being a single number group means. And I think this cell being marked as a number is now the next aha to kind of use here. It cancels this option and this option. So this is where the 3 group is going to go. This will be a 1, 2, or 3. Marking these cells off marks this off because this has to be a contiguous green group. Same thinking up here. So this can't be the 3 is down below. This is a double-digit sum, so it's got to take at least 1 more cell. That can't be this 3, so it has to be this 4. And that's still not a double-digit sum, so this cell has to be taken. And we no longer can take these, so these get marked in. And so this may be a trick that you didn't catch on to, but looks like a necessary way to get a lot of fast progress, including the fact that we've now actually finished this top row. So that gives us this 14, takes 2 cells, these connect, the 10 and 15 split, these connect, these have to be marked off. This is a double-digit sum, so this can't take only 1 cell. And actually it can't take a 7 if the only options here are 1 with 2. Now this has to be 9, that's 7. Actually gives us 5 with this 7. So that should be pretty helpful. What does that do? Well, those 7s mean that we can't have another 7 in this row, so where this 15 could be 7 plus 8, it no longer can. This has to be 6 with 9. What else can we mark off? This is 1 with 3. This is 1 with 2. This with the options remaining has to be 2 of 5. We actually have some constraints that are more about the sums. So one first thing I see, if this is an 8 or a 9, we're leaving behind 12 or 11 as remaining ones. So we don't have large values. We can go as large as 6. 8, 6, 1, 2, 3 is a way this can go. So this cell can only be as large as a 6. But with a 14 sum, it has to be a 5 or a 6 with an 8 or 9 here. that now forms a pair, but I can't do more of it yet. I actually see that this 5 with this 6 would be incompatible with the rest. This is 2 up above, 5 down below. This 1, 2 actually means this is 3, 4. Can this work if this is not a 1? So this 20 sum with an 8 or 9 as a value of 12 or 11 always needs to have a 1 in it, so this has to be 1 with 6. So you can force that. This always also has to have a 3, so it looks like the only degree of freedom is if these are large or small, but I can't do more than I just did in this space, so hopefully this is enough to get some progress. The interesting value is probably now this unmarked cell, or sum, that's a 10. It's not 1, 9, or 4, 6, and it's also not 3, 7, so this has to be 2, 8. This being a 1, 2 pair says this can't be a 2, so this is an 8 here, puts in a 2, 1, 2, 1, 2. 7, 1, 2 adds up to 10, so this has to also add up to 10, and 9, 1 doesn't work anymore, so this is 6, 4, 9, this is a 6. That 6 puts this in as a 5, 9. That leaves behind just 7, 8 down below. It's an 8, 9 here. All of these values leave just a 3, 7 down below. And there's something we haven't used yet, but may be helpful now, which is that you can actually, at different stages of the puzzle, identify like what these question marks equals. Like these 5 values are 20 plus this, and these 5 values are 20 plus this. So let's just understand what's the sum down here. 10 and 10 is 20, 14 and 4 is 18, 15 is 33. So this is 33, and 33 can't have a 1 in it, but it can have 3. It's actually going to have 6, 7, 8, 9 as remaining values here. So this is 6, 4, that 7 makes this 8, 7, and this has to be 9, 5. And there are probably also ways you could have used the limitations of this sum. Once we have this as a 7, 8, we need to have a 1 somewhere in here. But good workout to get through the puzzle. Some different uses of the double-digit question clues. The fast clearance on the right was a really interesting trait of this puzzle I hadn't seen before, particularly how it then worked in the columns to give us progress. So the different aha moments, getting this whole group, were probably key if you got stuck in the middle of the solve. So hopefully this video helped you see the light of how to get through the finish. Thanks, Prasanna, for this clever puzzle, and we'll see you again soon.